Preparing for a DevSecOps at MUFG interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What does DevSecOps mean, and how would you apply it in a regulated banking environment like MUFG? DevSecOps integrates security throughout software delivery rather than adding a final review. I would embed threat modeling, secure coding, automated tests, dependency scanning, infrastructure checks, and runtime monitoring into the pipeline. Developers own early remediation, while security teams provide guardrails and risk expertise. At MUFG, I would also preserve evidence, approvals, and segregation of duties required for regulated banking systems. This reduces late surprises without weakening control. While answering, explain security integration across the lifecycle, shared ownership, automation, risk-based controls, auditability, segregation of duties, developer enablement, and the balance between delivery speed and banking-grade governance. Question 2. How would you design a secure CI/CD pipeline for a customer-facing banking application? I would begin with protected repositories, strong identity controls, and mandatory peer review. Every commit would trigger secret detection, SAST, software composition analysis, unit tests, and infrastructure validation in isolated runners. The pipeline would produce a signed, immutable artifact and promote that same artifact through environments. Production deployment would require risk-based approval, policy checks, monitoring, and an automated rollback path. This design limits tampering while keeping releases repeatable and traceable. Make sure to cover source protection, branch controls, identity management, build isolation, SAST, SCA, secrets scanning, artifact signing, approval gates, deployment verification, rollback, and immutable audit records. Question 3. How do you perform threat modeling for a new MUFG payment service? I would map payment assets, users, services, data flows, and trust boundaries before implementation. Then I would identify abuse cases such as credential theft, transaction tampering, replay, privilege escalation, and denial of service. Using Stride as a structured prompt, I would assign mitigations, owners, and residual risk. For a banking service, fraud controls and non-repudiation matter alongside confidentiality. I would revisit the model after architecture or threat changes. In your answer, discuss asset identification, trust boundaries, data flows, abuse cases, Stride or equivalent methods, authentication, authorization, encryption, fraud risks, mitigations, and continuous model updates. Question 4. What is the difference between SAST, DAST, and SCA, and where would you place them in a pipeline? SAST examines source or bytecode without running the application, so I place it early for fast feedback on insecure coding patterns. DAST attacks a deployed application and finds runtime issues, making it useful in integration or staging environments. SCA inventories third-party libraries, licenses, and known vulnerabilities throughout the build. None is sufficient alone. SAST can miss configuration flaws, DAST lacks internal context, and SCA depends on accurate vulnerability intelligence. Be sure to mention source code analysis, running application testing, open source dependency analysis, timing, strengths, limitations, false positives, and how combining these techniques improves coverage. Question 5. How would you prevent secrets from leaking through source code and CI/CD systems? I would prohibit secrets in source, configuration files, images, and pipeline variables whenever possible. Pre-commit and server-side scanners can block obvious leaks, while applications retrieve short-lived credentials from a managed vault at runtime. Pipeline logs must mask sensitive values, and workload identities should replace shared static keys. If a secret leaks, I would revoke it immediately, investigate access, remove it from history, rotate related credentials, and document the incident. Focus on secret scanning, centralized vaults, short-lived credentials, rotation, least privilege, masking, secure injection, history cleanup, incident response, and preventing secrets from appearing in logs or artifacts. Question 6. How can infrastructure as code improve security, and what controls would you implement? Infrastructure as code makes security reviewable, repeatable, and testable. I would store definitions in protected repositories, require reviews, scan them for insecure settings, and enforce policies such as private storage, approved regions, encryption, and restricted network access. State files need encryption and controlled access, while modules should encode secure defaults. I would detect drift continuously and reconcile only through reviewed changes, preserving an auditable history for every environment. Cover version control, peer review, reusable modules, policy as code, static scanning, drift detection, state protection, least privilege, change traceability, and safe handling of sensitive values. Question 7. What security risks arise when running containers or Kubernetes workloads, and how would you mitigate them? The main risks include poisoned images, vulnerable packages, excessive privileges, exposed APIs, and lateral movement. I would use trusted minimal images, pinned digests, image scanning, signed provenance, non-root execution, dropped capabilities, read-only file systems, and restricted service accounts. Admission policies should block unsafe workloads before deployment, while network policies limit communication. Runtime detection and rapid patching complete the control set. Kubernetes security is layered, not solved by scanning images alone. Discuss image provenance, vulnerable packages, root privileges, capabilities, network policies, admission controls, runtime monitoring, service identities, secrets, isolation, and cluster upgrade practices. Question 8. How do you decide whether a security vulnerability should block a deployment? I would not use severity as the only decision. I would consider exploitability, internet exposure, affected data, transaction impact, asset criticality, available compensating controls, and whether exploitation is active. A critical vulnerability in an exposed payment component should normally block release. A lower risk issue in an isolated system might proceed with a deadline and owner. Exceptions require documented rationale, security approval, expiration, and continuous tracking. Explain risk-based decisions using severity, exploitability, exposure, asset criticality, compensating controls, business impact, remediation deadlines, exceptions, and documented approval rather than severity alone. Question 9. How would you reduce false positives in automated security scanning without weakening security? I would first classify findings using application context, exploitability, reachability, and asset importance rather than blindly suppressing alerts. Rules can be tuned centrally, while narrowly scoped suppressions require justification, ownership, and expiration. I would correlate multiple tools and route actionable findings to the responsible team with clear remediation guidance. Periodic reviews should examine ignored results and scanner performance. The goal is higher signal, not fewer reported vulnerabilities. Mention baseline tuning, centralized rule configuration, contextual validation, suppression governance, developer feedback, severity thresholds, tool correlation, sampling, and periodic review of ignored findings. Question 10. How would you manage a critical vulnerability discovered in production at MUFG? I would activate the incident process, confirm the vulnerability, identify affected versions and exposure, and assess evidence of exploitation. Depending on risk, I might isolate the service, disable a feature, tighten access, or apply a temporary virtual patch. In parallel, I would test and deploy the vendor fix through an emergency but controlled change. I would preserve logs, communicate clearly to stakeholders, validate recovery, and complete a blameless review. Be sure to cover triage, containment, affected asset identification, exploit assessment, emergency change procedures, patch validation, monitoring, communication, evidence preservation, and post-incident learning. Question 11. What is software supply chain security, and how would you strengthen it? Supply chain security protects the code, dependencies, tools, and artifacts used to deliver software. I would pin dependencies, use approved registries, generate an SBOM, scan continuously, and verify signed provenance before deployment. Build systems should be isolated and produce immutable artifacts from controlled inputs. I would also monitor suppliers and respond quickly when a library becomes compromised. Reproducibility and traceability make investigation and recovery much faster. Discuss dependency governance, trusted registries, SBOMs, provenance, signed artifacts, reproducible builds, version pinning, vulnerability monitoring, build isolation, and vendor risk management. Question 12. How would you secure cloud IAM for DevSecOps teams supporting banking applications? I would federate workforce identities, require phishing-resistant MFA, and assign short-lived roles rather than permanent administrator access. Human and workload identities should be separate, with permissions limited to specific resources and actions. Production access should use just-in-time elevation, approval, and strong logging, while break glass accounts remain tightly controlled and tested. Regular access reviews and unused permission analysis reduce entitlement creep without obstructing automated delivery. Cover least privilege, federation, phishing-resistant MFA, workload identities, role separation, just-in-time access, permission reviews, service account hygiene, logging, and emergency access controls. Question 13. How would you implement zero trust principles in a hybrid banking environment? Zero trust means no implicit trust based on network location. I would authenticate every user, device, service, and workload, then authorize each request using identity, context, device posture, and resource sensitivity. Mutual TLS, strong service identities, microsegmentation, and centralized policy enforcement reduce lateral movement. For legacy systems, I would add controlled gateways and compensating monitoring first. Adoption should be incremental, measurable, and compatible with operational resilience. Explain continuous verification, explicit authorization, device and workload identity, microsegmentation, least privilege, encrypted communication, policy enforcement, telemetry, and gradual modernization of legacy systems. Question 14. How do you maintain compliance and auditability while automating deployments? Automation should create stronger evidence, not bypass governance. I would encode applicable controls as pipeline policies, retain immutable logs for code, approvals, tests, artifacts, and deployment identities, and enforce separation between development and production authorization. Each release should link to a reviewed change record and tested artifact. Automated evidence collection reduces manual effort, while periodic control reviews confirm that policies remain aligned with regulatory and risk requirements. Focus on policy as code, immutable logs, approval evidence, change records, separation of duties, retention, control mapping, automated evidence collection, and reconciling speed with regulatory obligations. Question 15. How would you introduce DevSecOps when modern services must integrate with legacy banking or mainframe systems? I would begin by mapping interfaces, data flows, ownership, and operational constraints rather than forcing identical controls everywhere. APIs and integration layers need authentication, authorization, validation, encryption, rate limits, and detailed monitoring. Contract tests can protect compatibility, while staged releases and rehearsed rollback reduce operational risk. Legacy platforms may require compensating controls, but I would still track technical debt and create a practical path towards safer modernization. Mention dependency mapping, interface security, compensating controls, contract testing, staged modernization, change windows, monitoring, rollback, data protection, and avoiding assumptions that legacy platforms are automatically secure. Question 16. What DevSecOps metrics would you present to engineering and security leadership? I would combine security outcomes with delivery and reliability measures. Useful indicators include critical vulnerability age, mean time to remediate, escaped vulnerabilities, dependency coverage, exception aging, secret exposure incidents, and percentage of signed deployments. I would pair those with deployment frequency, change failure rate, detection time, and recovery time. Metrics should be segmented by asset risk and used to improve systems, not punish teams or encourage superficial closure. Include vulnerability age, remediation time, escaped defects, scan coverage, policy exceptions, deployment frequency, change failure rate, mean time to detect and recover, and metrics segmented by risk. Question 17. How would you secure and govern emergency production changes? Emergency access should be fast but never informal. I would define qualifying events, require dual authorization where practical, grant time-limited privileges, and record the requester, reason, commands, and affected assets. The smallest viable change should be tested and monitored, with a prepared rollback. After stabilization, the change must receive normal review, evidence reconciliation, and a retrospective. Temporary access should expire automatically rather than relying on memory. Discuss predefined emergency criteria, dual authorization, minimal scope, automated testing, evidence capture, monitoring, rollback, retrospective review, and preventing emergency access from becoming permanent. Question 18. How would you integrate security into an agile team without slowing developers unnecessarily? I would make the secure path the easiest path. Reusable pipeline templates, approved libraries, secure infrastructure modules, and concise scanner guidance help developers succeed by default. A security champion in each team provides local feedback, while specialists join early threat modeling sessions for high-risk features. Gates should be risk-based and fast, with exceptions handled transparently. This approach turns security into an engineering capability instead of a late-stage approval queue. Cover security champions, reusable secure templates, early consultation, developer-friendly tooling, risk-based gates, threat model workshops, clear ownership, training, and measuring remediation quality instead of adding bureaucracy. Question 19. A pipeline reports a vulnerable dependency, but upgrading may break a critical release. What would you do? I would verify the finding, determine whether the vulnerable code path is reachable, and assess exposure and business impact. I would test the safest supported upgrade, including compatibility and regression tests. If release risk remains higher than immediate exploit risk, I would document a short-lived exception with compensating controls, owner, approval, and deadline. I would still schedule permanent remediation rather than treating the exception as closure, and communicate the decision clearly. Explain validation of exploitability, dependency reachability, business criticality, compensating controls, upgrade testing, temporary exception governance, communication, deadlines, and prioritizing durable remediation. Question 20. Describe a time you influenced developers or operations teams to adopt a security improvement. In one project, developers resisted mandatory dependency scanning because previous alerts were noisy and delayed builds. I reviewed the findings with them, tuned rules, added reachability checks, and created a fast pull request scan with deeper scheduled analysis. We piloted the change with one service, measured remediation time and build impact, then expanded it. Adoption improved because the control addressed real risk without disrupting delivery. I learned that collaboration and useful feedback outperform enforcement alone. Prepare a STAR-style example covering the initial risk, stakeholder concerns, evidence, collaboration, incremental rollout, measurable outcome, lessons learned, and how you avoided imposing impractical controls. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.